Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class A. This is for session T24. All right, for question number one, Shannon and Suzanne average 68 miles per hour on a 390-mile automobile drive. They start driving at 8:40 a.m. Rounded to the nearest minute, when did they complete their drive? So you see 68 miles per hour, which is a rate, which is just another word for speed. And that's the average speed specifically. And you also see 390 miles, that's a unit for time. Distance. And what you want to figure out is how long did it take to complete the drive? So the formula that we're going to use here is the average speed formula, or the average rate. The average speed is the total distance divided by the total time. All right, it's just a variation of the distance formula, which is d equals r times t. Distance is rate times time. If you divide by t on both sides, you can actually get the rearranged version, which is rate is distance over time. So here the average rate would be the total distance over the total time. So this is something that you would have to memorize, because we're going to have to apply it for this question. So for this question, to get the average speed, or the average rate, you got the total distance, which is 390 miles, divided by the rate here we actually know, so the one we're looking for is the time. And if you rearrange the formula, d equals rt, time is going to be distance divided by rate. So that's the version that we need to use. So the time will be equal to the distance, which is 390 miles, divided by the total, the average rate, which is 68 miles per hour. You have to do 390 divided by 68. So when you do that, you can just estimate 68 to be about 70. So you would estimate that 68 times 5 is going to be kind of close. All right, and you get 340. So you have a remainder of 50. All right, so the answer is going to be 5 hours and 50 over 68. And here you can just simplify, or you can also estimate, because 68, if you divide by 2, you're going to get 34, which is not really a multiple of 68. So you can actually estimate this to be about 40 over 60. So it's about 2/3 of an hour. So it'll be about 5 hours, and with 2/3, that's about 40 minutes. So here we started at 8:40 to add 5 hours. It's going to be 13:40, which is really 1:40 p.m. And if you add another 40 minutes, that's going to give you a total time of about 2:20. So the closest answer will be choice B, because you have to just round to the nearest minute anyway. So again, for number 21, you have to use distance equals rate times time, and also the average speed is total distance over total time, to figure out the time that they take to drive these 390 miles. All right, next for number 22. Before conference swim championships, Suzanne's best time in the 200-yard butterfly race was 2 minutes and 23 seconds. In the conference championships, she won 10th place by swimming the 200 yards butterfly in 2 minutes, 15 seconds. What percent decrease is that? All right, so the keyword here is percent decrease, and the formula for percent change is new minus the old value divided by the old value times 100%. So again, this percent change formula is something that you will need to memorize. So in this case, the new time is 2 minutes, 15 seconds. the old time was 2 minutes, 23 seconds. So here it really helps if you convert everything into seconds, because if you have minutes and seconds, you can't really work with that time. So remember, 1 minute is 60 seconds. So 2 minute 23 would be 120 plus 23, or 143 minutes. And then 2 minute 15 seconds is going to be 120 plus 15, which is 135 seconds. So if you substitute into new minus old over old, the new time would be 135. The old time would be 143. So there's a percent decrease because you went faster, which is good in competitions. So it would be 135 minus 143 divided by 143 times 100%. All right, so here 135 minus 143 is 8 over 143 times 100%. So here you have to divide 8 by 143, because 143 is, you don't know any of the factors of that. So when you divide 8 divided by 143, I have to put a couple of zeros there. So you have to ask how many times does 143 go into 800, and you can just guess, let's say 6. Right, so 6 is a little too much. So now you have to go with 5. And then you have 850, which is going to be really, really close to 6. So you can kind of just estimate around about 6. And when you multiply 0.056 by 100%, you move the decimal to the right 2 places, so that's a 5.6% decrease, which is choice B. In reality, it's going to be like 5.59 something, but we can just round to 5.6. So again, here we have to use the percent change formula, which is new minus old divided by old times 100%. All right, next one, number 23, you got to place the 9 integers, -4 to +4, into the 9 boxes, so that the sum of the integers in any 2 consecutive boxes is a perfect square number. All right, there are 2 different numbers that could be in the middle square. What is the sum of these 2 numbers? All right, so you just have to place them together so that when you add any of the numbers in any 2 consecutive boxes, which means boxes that are next to one another, want to make sure it's a perfect square. So if you look at the perfect squares, you have 1, 4, 9, 16, etc. Obviously, everything after 9 you can't make, because the biggest number is just 4. If you take the biggest 2 numbers, 4 plus 3, that's 7. You can't even make 9. And if you take a look at some of these negative numbers, you add them together, there's no way it's going to give you a sum of 4 either. So the only perfect square you can probably only make is 1. So you're gonna try to put the numbers together so that you get a positive 1 somewhere. So for example, if you do a 4 first, the number next to it will be -3. They'll give you a sum of +1. And then, the other perfect square number will be 0, because 0 squared is 0. So you go +3 there. And then after a +3, you could put a -2, because 3 plus -2 is 1. And with -2, you can put a +2. And then from there, you could put a -1, then +1, then 0, and then 4. Actually, when you put a 4 there, you repeated that, so that would be, and you can't put a -4 here. So would be a variation of this. So you would actually put the -4 all the way to the left. So just restart that. Put -4 and +4, that would be a sum of 0. Then you put a 4 with a -3. This will give you a sum of 1, which is a perfect square. And then you do the same pattern. -3 plus 3 is 0. And 3 will put -2. And from -2 you put +2, and -1, and +1, and then 0. All right, so -2 could be in the middle. All right, so that's one way to do this. And then the other way to do this, you could also go backwards. Although that will give you just the same -2 in the middle. So then you would have to think about putting this in a different way. All right, so from here, you would just try with the next number. So instead of -4, you can just try -3. Just follow the same pattern. So -3, put +3, then -2, and put +2, then -1, put +1. And here you can put a 0. And 0 is a really important one because 0 can link up with 4, because 0 plus 4 is also a perfect square. And then you put -4 there. So in this way, -1 is also in the middle. And when you add -2 plus -1, you will get -3, which is choice A. So really the key here is to kind of figure out the only positive squares that you can have is 0, 1, and 4. Again, for number 23, just guess and check and just follow the rule. Again, here consecutive means next to each other. All right, next for number 24. What is the ratio of the measure of the interior angle of an equilateral triangle to the measure of the interior angle of a square? So for an equilateral triangle, all sides are equal, all angles are equal, and since the total is 180 degrees, if you do 180 divided by 3, you know that each angle is equal to 60 degrees. Now for a square, you have all right angles, so that's 360 degrees divided by 4, which is equal to 90 degrees, and that's why they're all right angles. So the ratio just means divide, so you'll have 60 divided by 90, and if you divide by 30 on both sides, you would get 2 to 3, or 2/3, which is choice A. Next for number 25, what is the smallest whole number value of n such that 30 times, or 30 raised rather to the nth power is larger than 10 billion? All right, so from here, 30 raised to nth power is basically 30 times 30, and then you keep multiplying by 30. But you know that 30 you can rewrite as 3 times 10. So what you're really doing is 3 times 10 in parentheses raised to the nth power. And then this is kind of like a distributive property going on, which is 3 to the nth times 10 to the nth. So now you can kind of track this, where you raise each one to the first power, then the second power, etc. And you want to see which one will be greater than 10 billion. Remember, billion is 10 to the 9th. So 10 billion means you have 10 to the 10th power. So 10 place values, or 1 followed by 10 zeros. All right, so here, if you start out with the smallest choice, because you're looking for the smallest, so start with choice A, you'll have 3 to the 5th times 10 to the 5th. Well, 10 to the 5th is a 1 followed by 5 zeros. That's 100,000. And 3 to the 5th, you would just do 3 times 3. So that's 9 times 9 times a 3. So that's 81 times 3, which is 243. So 243 times 100,000 would be 243 followed by 5 zeros. All right, so that's 24 million. So we're not that close. So you eliminate choice A. move on to the next one. So when you want to multiply by 3 again, you'll have 729. So this 243 turns to 729, and then you just add another 0. So that's 1, 2, 3, 4, 5, 6 zeros. So now you're already in the 729 millions. As soon as you add another 0, and for 729, when you multiply by another 3, you'll have another place value, so it'll be 4 digits. You'll have 2187. So it'll be 2187, and then followed by 7 zeros. Right, so that's going to be 21 billion. So of course that's greater than 10 billion. So the answer is going to be choice C. So for number 25, you want the smallest whole number value of n, such that 30 raised to the nth is larger than 10 billion. So you want to start with choice A, which is the smallest. And then you want to use this rule where you kind of use the distributor property to help you out. All right, next one, number 26, and the number, whatever. What digits is the 10 billions place? You just want to count. Here's the thousands, comma. Then you have millions, comma. So 6, 7, 8 in millions. After that, you have the billions. So the 3, 4, 5 is in a billion. Specifically, the 10 billions would be choice B4. All right, next for number 27, the drama club hosted a 2003-minute-long dance marathon. It started at 7 o'clock Friday. On Sunday, at what time did it end? All right, so here you want to figure out, the timing. You know that 60 minutes is equal to 1 hour. And you have 24 hours is equal to 1 day. So if you do 60 times 24, you'll have 1440 minutes in a day. So if you add 1440, not the full day, add another 1440, you have 2880. That'd be 2 days, so that's way too much. So here, if you take 2003 and minus 1440, now I had to borrow 3 times. You have 563 minutes left over. So after a full day, it'll be 7 p.m. on Saturday. So now you want to figure out how many 60s are in 563. So when you do 563 divided by 60, or you can just do 6 goes into, if you do 6 times, say 80, that would be 480, but then 6 times 9 would be 54, or 60 minutes times 9 hours would be 540 minutes. So you know you have to go 9 hours. So when you do 7 plus 5 hours, that would be 12 a.m. That would be midnight on Sunday. But you still got to go another 4 hours because you want to go 9 hours. You add another 4, so then 4 a.m. will be on Sunday. Now you do 563 minus 540, you get 23 minutes left. So you still want to add 23 minutes, and that'll give you 4:23 a.m., which is choice A. So the key here is to figure out that there are 60 minutes in an hour, and then if you do 24 times 60, that'll give you 1440 minutes in a day. So you just count forward. All right, next for number 28, 3 boys, Andre, Boyd, and Charlie, so ABC, and 2 girls, Deanna and Edith, so D and E, are standing in line for lunch. If the boys and girls alternate in line, how many different ways can they line up? All right, so this is a counting principle question, which is kind of like a tree diagram. So you want to put place values or slots for the boys and figure out how many choices there are. So they're 3 boys, and there are no restrictions, so they can be anywhere. So in the first position, you have 3 possibilities, A, B, or C. But since one of them is chosen for the first position, for the second position in the middle, you only have 2 possibilities left. Because someone else is first in line. And then for the last position, because 2 of the names are already used, you only have 1 choice left. So that's for the boys. And then for the girls, G1 and G2, you have 2 different girls. So you have 2 possibilities for the first position, or the second position in this case. And then the fourth position, I have just 1 possibility. And for the counting principle, you always want to multiply because it's a tree diagram. So 3 times 2 times 2 would be equal to 12. You can also write everything out because you can have A, B, C, A, C, B, B, A, C, B, C, A. And then you can also have C, A, B, and C, B, A. Those are the 6 positions for the boys. It's 3 times 2 times 1. And then from each of these, you can have 2 for the girls for each one. So you can have D first and then E, or E and then D. D and then E, or E, D. So for each of these 6, you can branch out another 2 times. For D and then E, or E and then D. So there's a total of 12 there. But the shortcut is the counting principle. All right, and here's the summary for this page. All right, next one, number 29. To build a fence around a square garden, Lisa and Homer use 12 fence posts, which are equally spaced 5 feet apart. What is the area in square feet of their garden? So it's a square garden, and they use 12 fence posts, which are equally spaced 5 feet apart. So they only have 12 points. So we start with 3. Remember, it's a square, so it has to be even. So we have this. This is already 8, and you have 12. So you're going to have to expand this out, which is 4. And this would be the 12. So it would be a 4 by 4. And remember, each of these spaces is 5. So it's really 5, 5, 5, or 15. So 15 by 15 for the area, which is side squared. It's going to be 15 squared, or 225. Choice D. So it would be 225 feet squared. All right, next, number 30. D is a non-zero digit. D0D is a 3-digit number with the middle digit of 0. The repeating decimal part of 2000 divided by D0D has a period of 4, except when D is equal to. All right, so here you have to just go through all the choices and just divide, because you don't know the divisibility rules for these 3-digit numbers. So you can try 2000 divided by 202. And try 2000 divided by 303, and so on and so forth. So here you can just estimate 202 times 8. You can also try 202 times 9. All right, so that will actually be 9. So it'd be 1820, which is another 9. So it'd be 99, remainder 2. So here you really want to make repeating decimals, so then you actually would have to keep going. But once you see that it has a remainder of 2, you see that it's actually going to keep repeating, because 202 doesn't go to 20 or 200, so it'll be another 2000. So you actually see this 2000 coming up again. So that's what this means by a period of 4, which means that the repeating decimal has 4 repeating digits. So, for example, 99.000, and then 202 goes into 2000 9 times. So it'd be 0.0009 repeating. So it's 9.9009, 9009, 9009, etc., etc. So that's not going to be the answer. You're looking for one that doesn't have a period of 4. All right, so go to the next one and just do 303. So again, you would just have to estimate here. So you multiply by 6. You see another 1818. All right, so you see the same deal here, but with just 6.6006. All right, you put another 0. And again, you keep putting 3 more zeros, so it'll be 6.6006 repeating. So again, that's another repeating decimal with a period of 4. All right, then you try 2000 divided by 505. And here, 505, you can multiply by 3. You see the same pattern, 1515. So this would just be 3. And we subtract. I put a 0 down. And 505 goes into 4850. Here you can guess 9 times. You have 45, 45. And subtract. All right, put another 0. And this would be 6. It'd be 30, 30. And here you get that 2 again. And then eventually it's going to repeat. So put another 0. So it'll be a 0 here. And put another 0. This would be the 3 again. So you would get this repeating 9603. So we can do 2000 divided by 505. You would get 3.9603, 9603, etc., etc. So that's the period that's repeating as a period of 4. All right, then you go to the next one. So try 2000 divided by 707. So this will only go in twice. And this would be 1414. Right, and then 5860, you would try 707 times the 8. It would be 5656. And try 2040. This would be a 2. And then when you have 6260, that would be 707 times, we can try 9, but actually 9's not going to work because it'll be 6300, so this will be another 8. Right, and you have 604, put another 0. So here, if it repeats here, it should have a repeating number here, but this would be another 8. And we have 6040 minus 5656. You don't have a repeating decimal at all. So this would be the answer, choice D. So you have to do long division and then just keep dividing. So it'll be 2.8288, and it'll be like 5, 4 something something. So it doesn't repeat, so that's why it's the answer. There's no repeating pattern. All right, so for number 30, you just have to kind of guess and check. And just divide until you have some repeating decimals. All right, next for number 31. An 8-foot cylindrical log is 16 inches in diameter. If the wood weighs 48 pounds per cubic foot, how much does this log weigh? You got to round to nearest pound. So for the volume of a cylinder, it's pi r squared times h. So here it has 16 inches in diameter, so it's going to have 8 inches as the radius. And you want to put everything in cubic foot. So the 8 inches, you're going to have to turn into 8/12 feet, or 2/3 of a foot. So the volume here is going to be pi times 2/3 squared times 8. So everything's in feet. And that's, you have to do the exponent here, and that'll be 4/9. That's 32 pi over 9. Now, it weighs 48 pounds per cubic feet, so you have to multiply this by 48. All right, so 48 and 9 has a common factor of 3, so you can at least simplify that. And then you are rounding, so 32, you can just cross out with the 3, it's going to form 11. You have 11 times pi times 16. So if you do 11 times 16 first, that's 176. And then when you do 176 times 3.14, which is multiplied by 3, be 528. So it'll be a little bit greater than 528. So choice D is the closest here. So just substitute into pi r squared times h. Make sure you put everything in feet, because everything's in cubic feet. And then just substitute in and multiply by 48. Next one, number 32. What is the positive difference in the area of a circle with circumference of 80 feet and the area of a square with perimeter of 80 feet? You have to round to nearest tenth of a foot. All right, the area of a square with a perimeter of 40 means that each side is going to be 1/4 that, or 20. So the area here is going to be side squared, which is 400. Now for a circle with circumference of 80 feet, where circumference is 2 pi r. So you want to solve for the radius r. You could do c divided by 2 pi is equal to r. So that would be 80 divided by 2 times 3.14. Now from here, you would have to multiply this, or you have to square it and multiply by pi again. So once you have the radius, the area is pi times r squared. So you have to multiply this by itself. And then multiply by 3.14. Which will cancel out with 1 to 3.14s at least. All right, and then we can simplify 80 and the 2 to form 40. So this will be 40 times 40 divided by 3.14, or 1600 divided by 3.14. So here you can divide. Now here you can probably just estimate, so if you just do 1600 divided by 3, it's like 533. So 533 minus 400 will be about 133, so it should be less than 133. So choice E is the closest to that. All right, next one, number 33. Among the 1,000 years from 1000 to 1999, how many are written with exactly 2 distinct digits? For example, 1010 and 1999. All right, so you could list them all out, but it'll take forever. So you have to think about how many different ways can you just select 2 different digits and then just write all of those years. So for example here, you can also do this 4-number counting principle method. Now, you are restricted in the sense that because it's only 1,000 years, the thousands place has to be a 1. So aren't that many places where you can put another 1. All right, so you have 1, 0, 0, 1. So if you choose like 1s and 0s, and you just want to look for a pattern there, you have also put a 1 in the 10s and a 1 in the 100s. But you also have 3 1s, so you're going to have 1, 0, 1, 1, or 1, 1, 0, 1. So those are the only ones with 3 1s. Or actually you have 1, 1, 1, 0. And then with 4 1s, it's just, actually you can't have 4 1s. So that would be everything with 1s and 0s. And then, so you do the same thing with 1s and 2s. Oh, there's also one more, 1,000. Because it's inclusive, which means you want to include the edges, the endpoints. So there are 1, 2, 3, 4, 5, 6, 7 different ways to do this. And now you can actually just replace each of these 1s, the 0s, with another digit. So 2, 3, 4, 5, 6, 7, 8, and 9. And for each of them, you have 7 different ways. So if you count from 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different digits that you can put in there. 9 times 7 would be 63. Choice D. So everywhere you see a 0, you can replace it with a 1. Or sorry, not a 1. 2. And then 3, and then 4, and then 5, etc., etc. So if you do the set for 1s and 0s, you can actually find the pattern for everything else. All right, next one, number 34. When hiking the Peralta Trail to the Wheeler Needle and back, Rick spent 60% of his time walking uphill, to Wheeler Zeno, and 40% of his time returning by the same trail. If he averaged 2 miles per hour uphill, what was his average speed for the round trip? So average speed is total distance over total time. All right, so here we pretty much have to do a weighted average. So if he averaged 2 miles per hour uphill, and his uphill time is, he spent 60% of his time uphill, you have to do 60% of the 2 miles per hour. And you have to add 40% of his return, which we don't know what it is. So here, you're going to have to substitute in to distance equals rate times time to help you out. So for his rate going uphill, it was 2 miles per hour. And we don't know how long he took to go up there, so we could just say T. Or actually, we know that if we call the total time equal to T, 60% of the time walking uphill will be a distance for going uphill will be the average speed, which is 2, times 60% of T. And then downhill will be the average, which we actually don't know what it is, so we can call that R, times the downhill time, which is only 40% of T. Now, one thing to note is that the distance going uphill, 2 times 60% of T, is equal to the downhill, R times 40% of T. So you have to set them equal. The distance is the same. It's the same trail. So you can set these two equations equal. So that means that 2 times 60% or 3/5 times T is equal to his rate going downhill times 40% or 2/5 of T. So here, a couple things cancel out. T will cancel out. The denominator 5 will cancel out. So you're left with 6. 2 times 3, which is 6 on the left, is equal to 2R. So his rate going downhill would be 3 miles per hour. So then you can do the weighted average. Or you can also do the total distance over total time. So the total distance, once you know that the rate going downhill is 3 miles per hour, we can substitute back in D equals RT for total distance and total time, or you can also use a weighted average formula, which is you do a percent times the actual rate. So you have to do 60% of the time going uphill, which is 2, and add that to 40% of 3, the speed going downhill. So here, just turn this equation to 3/5 times 2 plus 2/5 times 3. So that would be 6 over 5 plus 6 over 5, or 12 over 5. And if you do 12 divided by 5, that would be 2.4, which is choice C. So that's how you get choice C here, just by doing the weighted average. You can also find the total distance. It actually doesn't matter what the distance is. You can just call it D, and then just figure out the average speed that way using distance equal rate times time. All right, next for number 35, as shown, a sculptor attaches a 4-meter cube to the top of the 7-meter cube and then places the small 2-meter cube so that the faces touch both the 4 and the 7-meter cube. In square meters, what is the surface area, including the base, of the completed sculpture? All right, so here you want to start with the formula for the surface area of a cube, which is 6s squared. So first thing you got to do, find the big cube. The big cube has a side of 7. So the big cube will have a surface area of 6 times 7 squared, or 6 times 49. So you have 294. Right, now you're going to have to subtract a couple things. Well, before we subtract, let's find the surface area of the smaller one. So this is a side of 4, and this is a side of 2. So the medium-sized cube will be 6 times 4 squared, or 6 times 16, which is 96. And then the small cube will be 6 times 2 squared, or 6 times 4, which is 24. So if you add 3 numbers up, you have 294 plus 96 plus 24. You have 414. But some of the square gets covered up, so you're going to have to subtract that. Specifically, the base of the medium cube, the 16, you double counted, so you have to subtract 16. You have 398. And then also the smaller cube, which is 2 by 2, which is 4. You have 394. And then also this side of 2 as well, that gets covered up. Minus another 4, 390. And remember, you have to actually double each of these. Just forgot to mention that. So we actually counted it twice. So for example, the base of the medium cube, we added it twice in this 96 and this 294. So you actually have to subtract 32. 2 times base of the medium. Which have 382. And then same thing for the base of 2 here. This 4, we double counted. You have to subtract 8. 3 down to 374. And then we have this other duplicate with the overlap between the medium and the small cube, which is another 4, so I have to double that, which is minus another 8. And that's how you get 366, which is choice B. All right, next one, number 36. Given a square, how many distinct equilateral triangles share exactly 2 vertices with 2 vertices of the square? You have the square here. You want to figure out how many different equilateral triangles share 2 vertices with the same square. So you can draw a triangle up there, but also a triangle down there. That's with this edge. You can also draw the other ones for the sides, and also the other ones going that way as well. So let me redraw this. So you have one going that way, one going this way, one going to the bottom, and one going to the right. So you're going to have 8 here. And that's with 2 vertices that are also the edge. But you can also draw vertices so that they're diagonal as well. And the other way. So if we connect that diagonal length, you can also draw that equilateral triangle and those 2. So that's another 4. So 8 plus 4 will be choice E, 12. All right, here's a summary for this page. All right, next one, number 37, in sequence 0, 1, 2, 5, 12, 29. Each number after the second term equals twice the previous number plus a number before that. For example, 29 is equal to 2 times 12 and plus 5. Which of the following terms of the sequence is the multiple of 5? So here, obviously you don't want to write everything out to the 2000th term, but you just want to look for a pattern. So you have 0, 1, 2, 5, so 5, of course, is a multiple of 5. And then you just keep writing the next couple ones to see if we notice a pattern. So you have to, the goal, that pattern here, is twice the previous number, so it'll be 29 times 2. And you have to add the number before that. So you have to add this 12. And see that you get a multiple of 5, that's a 70. All right, so then you follow the same thing. So we kind of see just like 0, of course, is not a multiple of 5, but it does end in a 0. So you see that the first, then skip 2, then the next one, skip 2, and the next one. So you kind of predict that maybe this number over here will end in a 0 or a 5. So here to go to the next number, you double 70, which is 140, and you want to add 29. So that'll be 169. You do 169 times 2. And then want to add 169 to this. You have 507. All right, and you have 507, double that. And then add 169. And so that's 1183. So that's not a multiple of 5. All right, so let me just double check. Oh, sorry, there's a mistake here. All right, so the 169 should be good. Then you're not supposed to add 169. You're supposed to add the 70. So it's 338 plus the 70, which will give us 408. All right, so hopefully this number is a multiple of 5. So we do 408 times 2. And then you have to do A16, not plus 408, but plus 169. And you do see that it will end in 5. So there's your pattern. So pretty much every 3 numbers will end in a 5. So here you have the first number, 2, 3 isn't, but the fourth number, and 5, 6 isn't, but the 7th number, and 8, 9 aren't, and then the 10th number, etc., etc., etc. So if you find the pattern here, this is an arithmetic sequence, which means you keep adding the same constant. The first term, a is equal to 1, and then the common difference, d, is equal to 3. So the general formula, a of n, is equal to a plus d times n minus 1. So here, you want to know which one of these is a multiple of 5. You can just pick, let's say, 2,000. You want to see if 2,000 is part of the sequence. Like I said, 2,000 equal to the first term, which is 1, plus 3 times n minus 1. Or you just have to see that it has to be one more than a multiple of 3. That's probably easier here. So you can solve this using the arithmetic sequence. But here the pattern is just one more than a multiple of 3. Because a multiple of 3 here is, well, you start with 0, and then 3, 6, 9, etc., etc. So subtract 1 from all the choices. And only choice C is a multiple of 3. A multiple of 3, you can add the digits. So if you do 2 plus 0 plus 0 plus 1, 2 plus 1 is equal to 3, and 3 is a multiple of 3. So the 2,000 second term is also going to be a multiple of 5. All right, so here just find the pattern, and you see that every 3 numbers you get a multiple of 5. All right, next for number 38 on a copy machine. When a person selects option X%, the copy is X% of the original, where X must be 50 or larger. To reduce an original to smaller than 50% requires the user to first reduce the original and then to reduce a copy. To reduce an original to exactly 48%, which of these 3 sequences would work? All right, so here, if you select some X%, the copy is X% of the original. Remember, X% of the original means X over 100 times the original. So that means that you're shrinking this this copy. You're just doing you're multiplying by percentages. Now, X has to be 50 or greater. So if you want a 60% of the original, for example, you can just punch in 60. But if you want something to be less than 50%, then you're going to have to reduce it twice. So in order to get 48%, you're going to have to do a couple of sequences. So if you do a 50% of the original, that's 1/2. And then 96%, you would multiply by 96 over 100. And 96 times 1 over 2 times 100 will be equal to 48 out of 100. And that's going to be 48%, which is what you wanted. So Roman numeral 1 would work. So choice A is wrong. Choice C and choice Z are wrong. The answer has to be B or E because we saw that 1 would work. So when you do multiple percents, you just multiply them. So for choice 2, it's 75% or 3/4. And then from that 3/4, you do 64%, which is 64 over 100. So 64 and 4 can simplify to 16 and 1. And now 16 times 3 will be 48 over 100, and this is 48%. So Roman numeral number 2 also works, so you eliminate choice B. The answer has to be choice E. Roman numeral number 3 wouldn't work because 70% would be 7/10, and then times 88 over 100. Here you can simplify the 88 and the 10, just divide by 2. So you just have to do 7 times 44 over 500. So that's not going to be 48%. It's going to be some weird decimal. All right, next for number 39. A square with an area of 40 square units is inscribed in a semicircle. In square units, what's the area of a circle inscribed, of the square inscribed in a circle? All right, so here, a square with an area of 40. So here for a square, you can solve for the area using side squared. So if side squared is equal to 40, side would be the square root of 40, which you can simplify as 4 times 10, and that would be square root of 4 times the square root of 10, which is 2 root 10. So that's how you can simplify square roots. You would just find perfect square factors. You can also just leave it as square root of 40. It doesn't really matter. Or you can put 2 root 10. They mean the same thing. Anyway, so from here, since it's inscribed in a semicircle, you can just cut this in half. And what we really want to find is for this diagonal, or for when you cut it in half and you make a rectangle, and you want to find the diagonal of the rectangle. So if you divide 2 root 10 by 2, you will figure out that each of these sides would just be root 10. And this is actually one of your special right triangles, or just a right triangle, so you can do Pythagorean. So it would be a squared plus b squared is equal to c squared, where the hypotenuse is equal to c. So it's square root of 10 squared plus 2 root 10 squared is equal to c squared. 10 square root of 10 squared is 10. Here, if you apply the distributive, it will be 2 squared times 10, or 40. Is equal to c squared. So c squared will be equal to 50. So c would be the square root of 50, or this would be square root of 25 times 2, which will be square root of 25 times the square root of 2, or 5 root 2. So that's the radius. The radius is 5 root 2. Now you want the area of a square inside this circle, perfectly inside. So I'll draw the same circle. The radius of 5 root 2. And now you want to put a square inside here so that it perfectly fits. And the key here was that the diagonal is the diameter. So the radius is 5 root 2. The diameter would be equal to 10 root 2, which is double that. And now, for the sides, for a square, you have a perfect 45, 45, 90 right triangle. Or an isosceles right triangle, the sides on a ratio of x root 2. Here, the x root 2 corresponds with the 10 root 2. So each side of the square has to be 10. So the area of the square would be 10 times 10, or choice B, 100. All right, next for number 40. To win this game, you must start at one of the 15 buttons, follow the instructions on the button, and all subsequent buttons, and end at the exit. For example, 2D means you have to move 2 buttons down, while 3R means move 3 buttons to the right. All right, so in which column is the only button at which you could start? Press all 15 buttons and then land on the exit button on your last move. All right, so you just have to go through all the choices here for this game. So for choice A, you want to start a whole bunch of ways. So you can start here. You go down. So you go to the right. Then you go 3 to the right, 1, 2, 3. Then you go 2 down. So here you're already 1. So that's not it. Now if you start in the middle, it's the same thing here for column A, because you just go 1 to the right, then 3 right, and then 2 down, and then you win. So then the last one for A is this one here. We go 4 to the right, 1, 2, 3, 4. Then you go 2 left. Then you go 2 up. And you go 2 to the left, and then you go back. You start back at 1, so that eventually you'll go down and go all the way to the right, and then win. But you still miss this button and this button, so choice A is wrong. So eliminate that. All right, next for column B, you just start here. So you move 2 down, then you go 2 to the right, then you go 3 left, 2, 3, and go 4 to the right, 1, 2, 3, 4, and you go 2 to the left, you go 2 up, and go 2 to the left. And then here, we're back at A. You can go right down. You missed these 2 points. Then you try this one. You go 3 to the right. Then you go 2 down. And you won. So that's a really fast one. So that can't be it. Again, you got to hit all the buttons. All right, if you try the third column here, you go 2 to the right. Then you go 3 left. Then you go 4 to the right. Then you go 2 left. Then you go 2 up. Then you go 2 left. You go 1 down. And here you go here and win. So you still missed a couple of buttons. So B is wrong. We tried all 3. Then you just go to the next one. So for choice C, you start here. You go 2 left. And then remember, this is the same thing with column A. You win that way. All right, for C in the middle column, you start here. Go 1 right. Go 1 up. Go 1 right. Then go 3 left. Then go 2 left. And then here you go down 1 to the right, 3 to the right, and then 2 down. Again, you skipped a whole bunch of buttons. All right, so then you try C in the third column. You start here. You go 2 up. Then you go 2 left. Then you go 1 down, and here you still win that way. Right, so that can't be it. All right, actually, let me redo this one, the middle one. So here you go 1 to the right, then go 1 up, then go 1 to the right, and go 3 left, then go 2 down, and go 2 to the right, and go 3 to the left, and you go 4 to the right, and you go 2 to the left, and then you go 2 up, and then 2 left. There you go. This is the one. 3 to the right, and then you win. So the answer is choice C. So I think I did a mistake for that one the first time. All right, so for this one, you just go through all the choices. All right, hit the summary for this page. All right, next, number 1, the bar graph shows the grades of the students from 2 algebra classes. What percent of the students received an A, B, or C? All right, so A, B, or C means you have to add all of these. So that's 3, 1, 4, 9, 8, and 5. So you have to add 4 plus 13 plus another 13. You have 30 out of this 4 and 1. And then this is 2 and 3. So it's 30 out of 40. And that's equal to choice B, 75%, just part of a whole. All right, next one, number 2. To attend Zan's graduation from Williams College, Rick drove 1/3 of the 16-mile drive Monday and 60% remaining on Tuesday. To reach a college on Wednesday, how much miles must you drive? So you did 1/3 of 1260. So you can just do 1260 divided by 3. All right, so that's going to be 420 miles. So here you have to do 1260 minus 420. Just have 848 miles to go. And now you did 60% of the remaining distance. So that means that you still have 40% left for Wednesday. So you can just do 40% or 2/5 of 840. So you do 840 divided by 5. So that's 168 times 2. So that's 336, which is choice D. next one, number 3, ABDE is a rectangle and BCD is an equilateral triangle. All right, what's the measure of angle CDE? Well, for an equilateral triangle, each angle, they're all equal. So you can do 180 divided by 3, you got 60. And for a rectangle, they're right angles. So we do 90 plus 60, and that's choice E, 150. All right, next one, number 4, Kilroy incorrectly converted 4.35 minutes to 4 minutes 35 seconds. How many seconds was he in error? Remember, 0.35 is really 35 out of 100, and you can simplify that. If you divide by 5, that's 7 over 20. Now you have to multiply by 3 over 3 because there's 60 seconds in a minute. That's 21 over 60. So it's really 21 seconds. So you can do 35 minus 21, and you get 14, choice D. So remember, 60 seconds is equal to a minute, not 100. All right, next one, number 5. What fraction of the square is shaded? All right, so if you take a look at what we have here, this represents 1/8. This is half of that, so this is 1/16. And here, if you just divide all the 8s into 4 pieces, this would be 132. So if you change everything to the LCD of 32, it's 2 over 32. This would be 4 over 32. So you can do 4, 5, 6, 7. Choice E, 7 over 32 if you add the numerators. All right, next for number 6. If building road costs $175 per square meter, what is the cost to construct a 40-kilometer stretch of this road that is 10 meters wide? So first do the area, which is length times width. So you do 40 kilometers, which is 40 times, remember kilo means 1,000. So it's 40,000 meters times 10 meters wide. So you multiply by that length times the width. So you just count the zeros. There's 1, 2, 3, 4, 5 zeros. Now it costs $175 per square meter. So you have to multiply this by 175. So if we do 175 times 4 on the side, you get 700. But you still got to put the 5 zeros. 1, 2, 3, 4, 5. So that's $70 million, choice D. So just be careful. Kilo, remember, is 1,000. All right, next for number 7, write any 2-digit whole number. Create a 4-digit number by writing 1 9 in front of your number and a 9 behind your number. Add your 2-digit and 4-digit numbers and then divide it by 11. From that, subtract your original 2-digit number and then divide that by 21. What's the final answer? So here you can write any 2-digit number. So let's just put 10, the smallest one. So you want to create a 4-digit number, writing 9 in front and 9 at the end. And then add your 2-digit and 4-digit numbers. So you just add 10. So that's 9119. And divide by 11. All right, so you get 829. And then subtract your original 2-digit number. All right, so it'll be 829 minus the original, which was 10, which is 819, and then divide that by 21. All right, so here 21, you can just estimate, let's say times 9. Right, so the answer will be choice C, 39. So I'm assuming no matter what you choose, you'll always get 39 as the answer, which is pretty cool. All right, and here's a summary for this page. All right, next for number 8. In a 10-kilometer race, a runner averaged 3.5 minutes per kilometer for the first 2 kilometers and across the finish line with a total time of 41 minutes. For the final 8 kilometers, how many minutes per kilometer does she average? So 3.5 minutes per kilometer for the first 2 kilometers means that she spent 7 minutes, because because you just double that for 2 kilometers. All right, so then for the last 8 kilometers, or the total was 41 minutes. So you do 41 minus 7. For the last 8 kilometers, it was 34 minutes. So you want the average minutes per kilometer. So you take 34 and you divide it by 8. So 8 goes into 34 4 times. So it's 4 point something. And 8 goes into 20 twice. So it's 4.2 something. That's choice D. Next for number 9, how many hundreds are in 1 trillion? So trillion has 12 zeros. Because billion has 9. So trillion would have 12. So there's 1, 2, 3, 4, 5, 6. That's million. 7, 8, 9. That's billion. And then you put, that's 1 billion. You put another 3 and put a 1. That's trillion. Now if you divide by 100, 2 of the zeros will cancel out. So now you still have a 10 billion, choice D. All right, next for number 10, what's the product of the 12th and 13th prime numbers? So just write them out. Remember, 1's on prime. So I'm with 2. Then 3, 5, 7, 9 isn't, so skip that. 11, and 13, and 15 isn't. 17, and then 19. So there's 1, 2, 3, 4, 5, 6, 7, 8. All right, you have 23, 9, and then the 10th prime number would be 29. All right, the 11th will be 31, then 37, and then after that will be 43. If you want to do 37 times 43, or sorry, 41. 43 is the 14th. 41 is also prime. All right, so here, if you just do 37 times 41, it's 15, 17, choice C. All right, next one, number 11. Create 7 equations, 3 horizontal and 4 vertical, by placing any of the 4 basic operations in the 10 blank boxes. If the value for each symbol is $1 for plus, 2 for subtract, 4 for times, 8 for divide, what is the total value of the 10 symbols that are used? All right, so there are 10 blank boxes here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here you want to put equations so that they're kind of equal. All right, so you want to make sure they're equations. So here, start with this one. Like 15 blank something, 5 is equal to 9, so that has to be subtract. Because 14 minus 5 is equal to 9. All right, and then just keep doing that for the rest. 6 and 0.4 is 2/5. So you can't subtract or multiply, so you're going to want to try to divide. So when you do 6 divided by 2/5, that's really keep, change, flip. So you want to do 6 times 5 over 2. That is equal to 14. Or 15, rather. So this would be divide. All right, so then negative 32 times half is negative 16. And then negative 40 divided by 4 is negative 10. All right, so then when you go across, well, 6 and 14, that's 20. So that's already too much, because you want negative 40 at the end. So if you do 6 minus 14, though, you'll get negative 8, and negative 8 plus negative 32 will be negative 40. That's good. All right, then for going across, you want final answer to 4. So if you do 0.4, let's say you multiplied by 5, that's 2/5 times 5 would be 2. And then 2 divided by half would be 4. All right, and then for the last one, you want an answer of -10. So if you do 15 plus 9, that wouldn't work. So you want to try 15, let's say -9. If you do 15 minus 9, you'll get -6. You'll get +6. And then 6 minus 16. So 6 really plus -16 will be equal to -10. All right, so then the total value for the 10 symbols, well, in terms of addition, you have one addition here. You have 2 additions. So that'll be $2. And then for subtract, you have 1, 2, 3 subtracts. That'll be $6. And then for multiply, you have 1, 2 to multiply. So that'll be $8. And finally, for divide, you have 1, 2, 3 divide. And that's $24. So you have to do 24 plus, 2 plus 6 is 8, and 8 plus 8 is 16. So 24 plus 16 is 40. Choice D. All right, next one, number 12. The Congressional Budget Office projects that the total U.S. debt will increase from 6.2 trillion to 8.9 trillion. What's a projected annual average annual increase in debt for this 12-year period? So 6.2 to 8.9. If you do 8.9 minus 6.2, that's 1.7 trillion. But here between 2002 and 2014, the years will be 12 years. So you want the total divided by 12. So if you do 1.7 divided by 12, you get 1. It is in trillions. So 0.14 trillion. Oh, sorry, this is 2.7. Excuse me. Because none of the answers are in 1.4. So this will be 2.7 divided by 12. So 12 goes to 27 2 times. 24 and 3, put a 0. 12 goes into 30 2 times. So it's 0.225, and remember it's in trillions. So we have 0.225 trillion. If you multiply by 3 here, or multiply by 10 cubed, you're going to have to remove 3 of the zeros. So this would be 225 billion. That's choice B. All right, next one, number 13. The colors of the 5 rings shown are blue, green, red, purple, and yellow, not in that order. Blue does not intersect with green. Purple intersects only with blue. And then red is to the right of green and is on the same horizontal level as green. All right, so here, you just kind of use process of elimination for this these intersecting circles. So purple only intersects the blue. So either 1 or 5 is purple. So either 2 or 4 is blue. Now, the blue cannot intersect with green, so whichever one it is, 3 can't be green. But wherever the green is, the red ring is to the right of the green ring, and it's on the same horizontal level as the green ring. So red has to be all the way to the right of green. So you can't have green in position 1, because then that would be red here. And one of them has to be purple. So therefore, you must know that green and the red has to be on the bottom. To be green, to be red, or rather, because then the blue gets canceled out, so never mind. So one of the ends would have to be green. So this would be purple, this would be blue, the middle would be red, and then yellow would have to be here. So here, blue does not intersect with green. That's true. Blue is 4, green is 1. Purple only intersects with blue. That's the 5 and the 4. And then red is to the right of green, so 3 is to the right of 1, and is on the same level. So yellow has to be 2. All right, next one, number 14. A positive integer less than or equal to 50 is randomly selected. What's the probability that a number selected is a multiple of 5, but not a multiple of 3? So you have a number less than or equal to 50. So that's from 1 to 50. There are 50 numbers here. And you just want to know the probability, how many numbers that are multiples of 5, but not multiples of 3. Just write out the multiples of 5. And you want to include 50. So you want multiples of 5, but not 3. So 15 doesn't count. 30 doesn't count. 45 doesn't count. The multiples of 15 don't count, because that's the LCM of 5 and 3. So what you really have left is just 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 50. And if you multiply by 2 over 2, that's equal to 14 over 100. And that's equal to 14%. So for choice B, there's a 14% chance that this will be selected. All right, here's a summary for this last page. All right, thank you everyone for joining me today, and I'll talk to you guys in the next one. All right, bye everyone.